Let's move on to the last test of chapter 12, which is the test for homogeneity of proportions. So in a chi-square test of homogeneity, we're testing whether the different populations have the same proportion of individuals with some characteristic. The null hypothesis is that the proportion for group 1 is equal to the proportion for group 2 is equal to the proportion for group 3, and so on, all the way up to the end. So that's the only difference between that and a test for independence, is how you set up the null hypothesis. In other words, all right, a test for independence is assuming that everything is from one population. And you're trying to say, hey, looking at all these people in one population, is their happiness and income, are they independent of each other? Down here, what you're doing is looking at different populations and trying to see whether the proportions are equal or not. It's going to look very similarly to an independence test, but it's not because of the way the sample was drawn and the way the population is thought of, or populations. So here we have a study of television viewing habits of children. A developmental psychologist selects a random sample of 300 first graders, 100 boys and 200 girls. Each child is asked which of the following TV programs they like the best: The Lone Ranger, Sesame Street, The Simpsons, and the results are shown in the contingency table below. So here you go. Then first job is to find the expected frequency for each cell. Well, that's not really going to change from how we did it before. So let me just remind you. Here. Oops, a little too big. So what I'm going to do is I'm going to copy and paste all of this in. All right, let me clean that up. Hold on one second. There we are. Now we have our spots for our expected frequencies. So let's just remind ourselves, we don't really need the row and column total. I mean, I can leave them in there. It doesn't really bother anything. So it's equal to the the row total, which would be 100, times the column total divided by the grand total. Now the thing I want to do is I want to make it, the grand total is right there. I want to give the grand total and my row total dollar signs. That way when I drag it across, because I'm about to drag it across the row, nothing will change. All right, then I want to do it again for the next row. So it would be 200 times 100 divided by 300. And I'm going to give the 300 dollar signs as well as the 200 dollar signs. That way when I drag it across, everything's great. Okay, so now I've got my expectations all filled out. Let me see if I can put them in here without having the whole computer freak out on me. Awesome. All right, now, do the the boys' preferences for TV programs differ significantly from the girls' preferences? And that's going to be your hypothesis test. So step 1. Hold on, let me type this up. I'll be right back. There we go. It's a little bit complicated of a null and alternative hypothesis because the null hypothesis is multi-tiered. Because you're saying, all right, the proportion for boys for this show is equal to the proportion of girls for this show. And then you're doing it again for the next group and so on. All right. So all of those constitute the null hypothesis. And the alternative is that at least one of those hypotheses is not correct, right? At least one of these proportions is different from the others. Hold on a second. Oops, there. That's a better way to say it. That at least, actually, that's the correct way to say it. That at least one of those null hypothesis statements is false. At least one of them is different. The way I had it written before wasn't quite right because it would imply that they're all supposed to be equal, which is not the case. All right, step 2, we know that alpha is equal to 0.05, so that's done. Step 3, we're going to need our test statistic. All right, the test statistic is just what it's been for the last couple tests. It's, oopsie, a big chi-square thing. Well, let me go get it. There it is. All right, again, you're using the same test, if you will, as a test for independence. It's not going to work very differently in terms of how you do it. It's just going to work differently in how you think of it. Again, this is for multiple proportions, multiple populations. Independence only talking about one population. All right, I'm not going to have time to do this, but let me get it started. So what we're going to need is we're going to need the observed, so parentheses, observed was 50 minus the expected, close parentheses, square it, and divide it by that expected value. And I'm going to do that for all of them. So you can just kind of drag over and drag down.